Hi guys, so welcome back to my channel. So in this video series we are going to create a full stack decentralized voting application where we have written a smart contract on the blockchain network which is going to take the votes for the candidates. And first of all we can go and we can connect our MetaMask and we can see the list of all the candidates. I have added some candidates in the constructor of the smart contract, so let's try to add a new candidate. So let's see, we with this function in the smart contract we can add a candidate and okay, so it's added. So let's again connect the MetaMask and list all candidates. So you see we have another candidate here, and let's go to vote. We can so we also have some functions in the smart contract where we can check the voting status. So voting is currently open and it is the time remaining is 1296 seconds. So actually I have opened the voting for 5 minutes, and you can actually put this information in the constructor of the smart contract, which we are going to program in the next video. So the voting is currently open and this time is remaining, and let's try to select an account here. Let's say I'm going to select this and let's connect it and add index of voter. So if we go here and we see, let's vote to mark. So connect and make it 0 and let's add vote, and we are going to confirm the transaction. In the meantime, if we see check voting status, you see it's 1104 second, and I think the vote has been added. So let's go here, connect MetaMask. Okay, so it's added now, and let's list all candidates. So you see the vote is here, so we can see the vote, and then again we can come here, we can check the voting status. It's 1072 second, and if we refresh it, connect MetaMask again, so 1029 seconds. So the remaining time is decreasing. Voting is currently open and we can add the candidates, and we can send votes to the smart contract, and it is being added here. And in the when the voting is finished, we can see who won the election. So it's all about this application. In this application we are going to write front end, we are going to write back end, and the smart contract which we are going to store it in the blockchain network. So stay tuned, I'm going to upload more videos and I'm going to program all these things in this video series. So let's move to the next video. Thank you. Hi, so welcome back. So in this video we are going to program our voting smart contract, and we will have different functions, or like vote or add candidate or getting all the votes of a certain candidate. And then we are also going to define the current status of the voting mechanism, like it's either it's open or closed, or what is the remaining time. So first of all, let's start a node project, npm init, and I'm going to copy and paste instead of installing everything individually. I'm going to copy and paste this dependencies here. So after license, I'm just going to copy and paste dependencies, and I'm just going to do npm install. So it's going to install all the dependencies. Let's wait for it. Okay, so it's almost finished. So okay, so it's finished. So we are going to first start npx hardhat. We are going to start a hardhat, create javascript, voting. Okay, our project is started, and now we have, instead of this, we are going to create a voting.sol, and we will start writing our code. So first of all, spdx dash license identifier MIT, so it doesn't give us the error, and pragma solidity, this is just to define the version of the solidity we are going to use. Then we have our contract voting, and in this contract, first of all, we need to define a struct which is candidate, and how we are going to represent it. It has a name, string name, and it has uint 256 vote count. So we are going to define a struct where a candidate has a name and the vote count. We can also add other things, but for right now, let's keep it simple. And now if we want to create an array of this struct, what we can do is simply write the struct name candidate, then put array and public and candidates. Okay, and then we are going to define an address owner who will be the owner of the smart contract, and then we can define mapping where we are going to say which address has already voted. So it's bool. So for every address we have a bool, either true or false, that this man or this person has already voted. So we are going to keep track of it. And then we have uint 256 of public voting start. So this is the start time of voting, and similarly voting end. And then we have constructor, it's a function, and it's going to take a string array which is candidate names, and then it is going to take the amount of time we want to keep this voting open, and then we can say duration in minutes. And what we are going to do is we are going to create a for loop where uint 256 of I is equals to 0, I is less than underscore candidate names dot length, and I plus plus. We are just going to push all these candidates in the candidates array, candidates dot push candidate, and then we are going to say name underscore candidate name of I, and the vote count is 0 because we are just starting with a 0 vote count. Okay, so our vote count is 0 now, and okay, so it's giving us error here. What is the error? Okay, vote count is 0. I think it's a syntax error, and let's like I think we are going to close it. Expected this. Oh, this is the error. Okay, and now since we have put all these names here, so what we can do is we can, okay, this is the for loop, and then we can say honor is equals to message dot sender, voting start is equals to block dot timestamp, and voting end is equals to block dot timestamp plus we can we are inputting duration in minutes, and we can multiply it with 1 minutes. So when we are going to give this, let's say 60 into 1 means 60 minutes. So basically that the voting duration will be 1 hour. So this is our constructor. Now we are going to create a modifier only honor. It means that only honor can run this required function, where we are going to put the only honor message dot sender is equals to honor, and the syntax says we have to put underscore. And now we have created our function modifier only honor. So let's create our first function where we are going to add a candidate, and we need to, because the vote count will always be 0, so we just need to specify the name string memory underscore name, and the function is public. First of all, we need to see two conditions. No, so okay, so this function is instead of putting the conditions, we can put only honor. So only honor can call this function, and we are going to say candidates this array dot push candidate, and name is underscore name, and vote count is 0. So that's how we are going to do it. This add candidate function is written. Now we are going to create a function vote, where we are going to give the index of the candidate whom we want to vote. So the index can be represented as 256 underscore candidate index, and this function is public. And we are not going to put the modifier only honor here because anyone can vote. Well, there is something, we can create an array and we can define the allowed addresses, like who can vote, but it will take like it's going to prolong this video, but I don't want it. And let's say like any public entity with the MetaMask address, they can actually call this vote function and give the vote to the candidate. So we need different conditions. The first condition is voters. We have our mapping of voters. So voters message dot sender, otherwise you have already voted. So basically it's saying that if this is true, then we are going to say you have already voted, and we are going to give another underscore candidate index should be less than candidates dot length, and we are going to say invalid candidate index, or the candidate doesn't exist. And then we are going to say candidates of underscore candidate index dot vote count plus plus, and we are going to assign voters of message dot sender is equals to true. So basically what we are doing is we are first checking if the voter has already voted or not, or if the candidate index is right, and then we are going to increase the vote count by 1, and we are setting voters of message.sender is equals to true. It means that once the voter has already voted, he or she cannot vote again. And then we have a function get all votes of candidates, and we can say public view returns. It is going to return us the struct array candidate. This is the struct array, and we are going to store it in memory, and we are going to return this array. Because it's a struct array, we are going to return this array, and once this array is returned, it's a tuple where it is going to give us all the information of the candidates. And now we have created these functions. Let's create get voting status. It's a function, and it is going to return if the voting returns bool. Why? Because it's going to tell if the voting is still open or closed. And we can just return, we can say block.timestamp is greater than equals to voting start, and there is another condition that the voting time, the block.timestamp must not be greater than the voting end. So this is our voting status. And finally we have our last function get remaining time, and it's going to give us the remaining time in seconds. Public view returns uint 256. Okay, and this is our function. First of all, we need to mention that the block.timestamp should be greater than equals to voting start, otherwise we are going to give error voting has not started yet. And then we are going to see if block.timestamp is greater than equals to voting and return 0, otherwise return voting end minus block.timestamp. So our smart contract is ready. First of all, we have defined candidates, and then we have created array. This is the owner, and these are the voters who are going to vote. And in the constructor we are pushing all those candidates in this array, and then we are defining the start and end time, and then we have defined only owner, that only owner can run the function. And then we have add candidate function, vote function, get all votes of candidates function, voting status, and get remaining time. So our smart contract is almost ready. So now let's move toward the front end. So thank you. Okay, so we have created our smart contract already. So now we are going to start our application with the backend. So let's create a file, index.js. Yeah, okay. Oh, it created a file index.js inside. Okay, so just forget it. Index.js so our index.js is ready. So we are going to write our backend code here. Basically, the application which we are creating, we can do everything in the front end, but just for the sake of learning, I am creating a backend server where we are going to serve our HTML file and some other HTML files associated with this project, and then we are going to create a simple post request, and we are going to add vote using the post request. We can do it in the front end in the JavaScript, but just for the learning I'm going to do everything here. So first of all, we are going to say .env.config, and we are going to take our environment variables, require, express, it's same old thing which I have to write all the time in all the applications, so just bear with me. And we are going to write file upload. It is going to take the JSON structure and sends from front end to back end, and we can extract everything inside. So this middleware is going to help us represent the data in the correct format. And then we are going to app.use express.static. Why we are using this? Because we are going to serve the static files using this backend, because we are going to write the JavaScript file with the front end. So we have to give everything there. We have to like serve this in our backend, so whenever a front end tries to connect with the backend, it can access those JavaScript files through this backend repository. And then we can use express.json const path is equals to require path const ethers is equals to require ethers. We can say port. You can find all this code in my previous project too, but just for the sake of like this new video, because there is a possibility that some people might not have seen my previous video, so I'm just writing everything again. Private key. We are going to create these environmental variable files later, so let's just write code first. Contract let's create the env file so you people don't get confused. And this env file is created, so I'm just like copying and pasting these things here. So okay, so where is the index.js? Okay, so you see we have this API URL, this is the private key of my account, and this is the contract address. So don't worry, we are going to deploy the contract and we are going to put the right address here. So we have defined these variables. Now what we can do is, in order to communicate with the contract, we need the contract ABI. So we can say const ABI is equals to require. It's in the artifact. Oh, I'm so sorry for that. So we have not yet and compiled our contract which we have created in the previous video. So npx hardhat and compile. The contract is compiled, and this is the voting, and this is the script to deploy. So let's just remove everything from here, and console.log. We can just say contract address, and we can say it's voting, and voting underscore equal to voting dot deploy, and it's voting underscore dot deployed. So I hope it's voting underscore dot address. Let's see if it works, otherwise we have to change this. npx hardhat run dash dash network volta scripts dash oh no, it's deploy.js. network volta doesn't exist. Okay, so we are going to copy these things here. Actually these are just like copy and paste it. So this is a volta network and this is the API URL, the private key. So let's do this again. Unlock time is not defined, I think. Okay, so deploy, let's just deploy. Missing argument in the constructor. Okay, okay, so here if you go to the voting.sol, we need to give two constructors, like candidate's name and the duration in minutes. So what we can do is we can give candidate name as Mark, Mike, George, and we can say the contract is on for let's say 20 minutes, because here if you see we need to give duration in minutes. So let's do this again. Okay, so our contract is deployed and we can just go and copy paste this, and here we need to define const abi is equals to require. Sorry for not compiling the contract before, but yeah, now you know that before writing the backend you need to compile the code, and dot slash artifacts slash contract slash voting.sol slash json. So it is going to get the json file here, and now our now we need to define a provider. Const provider is equals to new ethers dot providers dot json rpc provider, and we are going to put the API URL inside. Now the provider is ready. Now we need to define a signer, new ethers dot wallet, and we are going to give private key and provider, and then we can create const contract instance is equals to new ethers dot contract. So we need to give contract address, ABI and signer. Okay, so now everything is ready. Now we need to define our routes. Okay, we can say request response, and this is a function. So it's whenever we call this res dot send file, we can say path dot join underscore directory name, and it's going to serve index.html, and if somebody says index.html, then it's going to do the same thing. And now we can first, before writing our post request, we can say app.listen port function console.log. This is a callback function which is going to return this string listening on port 3000, not 30,000. Okay, so our backend is almost ready. Now we need to write just one post request, and the name of the post request is /vote. So whenever a user is going to click on vote function, he will be redirected, or he or she will be redirected to this post request. So we can say async is a function, and it has like request and response. So the request has the body. No. Okay, I always get confused about the syntax. Okay, so first of all, it's from the body we are going to extract the vote, which is actually so I think this function is implemented using the add candidate. So basically we are adding a candidate using this. So it's not actually vote, we can say it's add candidate, because we are going to call the function, and this console.log, we can just like console.log vote, or we can say it's candidate. Let's just don't complicate the things. Async function store data in blockchain. Actually it's my way of writing the code, so I am writing everything in the function, and then I'm going to call this function later. And I do this almost all the times in my projects. So if you go to my other videos, I must have done the same thing. So we are just going to say console.log, so the user wait, and then we are going to send a transaction which is await contract instance dot add candidate. This is the function we defined, and it takes a string of name, and then we can say await tx dot wait, and then we can create const bool is equals to await contract. I will explain what I'm doing right now. Okay, so we are actually getting the voting status, if the voting is open or closed. If it's, now we are going to say if bool is equals to true, if the voting is open, then we are going to call this function store data in blockchain, and we are going to give vote. And then we are, once it's done, we are going to say the candidate has been registered in the smart contract. Actually I'm not able to run this code right now because I have not created the HTML file. So as soon as I create the HTML file, I'm going to run this code to show you how it works. So we have said res.send the candidate has been registered in the smart contract, and else if the voting is closed, res.send voting is finished. I think the time I will complete this backend code, I think the voting will be finished because we have already deployed our contract, but it's okay. Like we can actually confirm this res.send voting is finished command. Otherwise, if the voting is open, we can see if we can add a candidate or not. So our backend is almost ready. So now we will move toward the front end part, the HTML file, and then as we are creating our HTML files and the code in the JavaScript, we are going to test the functionality step by step. So thank you for watching. So welcome back to this video series again, where we are creating the voting decentralized application. Now it's the time to create the HTML front-end files, and then we are going to create the JavaScript, vanilla JavaScript associated with those HTML. So first of all, we are going to create index.html, like which has where we can add our vote, and then there is a file list voters.html where we are going to list all the available voters, no sorry, the candidates in a table. And then there is also a functionality in this page where we can actually add a candidate, and then we can see in the real time if the candidate has been updated. So we are going to start from here. This is this is the most boring thing actually I want to do. So I'm sorry for that, but I just copied and pasted all this script, all these styling and these script source from my previous projects, and for main.js we can create it, because I don't want to write everything from like scratch and like do this, because it will take a lot of time. So instead of this thing, I want to focus on the functionality of application, and that's how we can do this. So first of all, we can say div, and we can say the class of this div is navbar. So we are going to create a navigation bar, and again this is HTML CSS stuff, so I don't bother just copying and pasting it. So let's copy and paste it. So I just don't want to spend a lot of time here. So this is just a navigation bar, and then we have this div where it is going to say that welcome to the decentralized voting application. And okay, so here we are going to create a button. So let's create it. So let's say it's a button. We have on click, the function will be connect MetaMask, and here we can say it's connect MetaMask, and then we have a simple a paragraph with the ID of MetaMask notification. It is going to update if the MetaMask is connected or not. And then after that we have a div of class container, and first of all we have a span vote here, and then we are going to have an input of type number. The ID of this input is vote, and placeholder is add index of the voter. This input is going to take the index of the voter, and then we are going to add a button, and on click is add vote. We are going to write all these functions in our main JavaScript file, but first let's create the most boring part of this project, which is HTML. And then we have, let's say, ID of candidate, and okay, so this is finished. And then what we can do is we can have another div where we are going to click say it's a button, and the on click is vote status. So it is going to give us the voting status, and we can say it's check voting status. And after this button we can create 2p. 2p means 2 paragraph. The ID is status, and another ID is time. So these are 2 paragraphs. So in this status we are going to say either it's a true or false, like the voting is open or finished, and then this time it's the remaining time. So we are going to click on this function, and the function is going to update these values. So our HTML is almost ready. So what we can do is we can say node index.js. So the server is running. We can go here, localhost 3000. Okay, so we have this connect metamask function. Then we can add a vote here and we can check the voting status. And the list voters.html has nothing inside, so we are just going to write list of voters. I'm just going to copy and paste things here and right here in the body we are going to change. So we have this will be same like connect metamask. We are going to just remove it. The nav bar will be same, connect metamask will be same, and here it's going to be changed. You remember in the backend server we have created this add candidate. So now we are going to call it from this HTML file. So we are going to create a div and its class is container. We are going to create a form. Action is slash, what is the action? Add candidate. The action is, why it is not working, add candidate, and let's go here. And the form, the method is post. No, the method is post, action is this, and enc type is multi-party form data. And in the form we first have a span add candidate here, and then we have an input of type text. The name of this input is vote. We are going to name it vote because it is going to take this value, this vote, from the request.body. So we need to make sure we use the right name, vote. And let's say the placeholder is add name of the candidates. And then we have an input of type submit, and value will be add candidate. So the name of this input type submit will be add candidate. So our form is ready. Let's go and see. Go to list voter. We have this add candidate. We are going to adjust its width, no problem. We have this add candidate. Now we need to remove this check voting status and we need to put a table here. So let's go here and yeah, okay. So after this, just remove it. Let's create a div, and we can say we are going to put a button, and on click will be, we are going to write all these functions later. Get all candidates, and the button is going to list all the candidates, and then we are going to add a p with id is equals to p3, which is going to tell the it's going to fetch, or what is the status of this fetch request. And then what we can do is we can create a simple id of voting status. We will see later, it's not a problem. And then we are going to create a table where we are going to create div table id is equals to my table. It's same like my previous project. THEAD TRTH1 its index, and then in the second it will be candidate name, and finally candidate votes. So let's go here. Okay, so we have, first of all we are going to connect MetaMask, then we have this add candidate, then list all candidates, and when we are going to press this button, it's going to create this table, and this input type text, let's create, no, let's say 100%, no, not 10, 100. Okay, so now the name of candidate will be here, and then add candidate and list all candidates. So now our HTML is almost finished, and now we are going to start writing our code in main.js. So thank you for watching this video. We will write this main.js in the next video. Okay, so we have created our front-end HTML and CSS file. So now we are going to add the JavaScript functionality to our front end. So let's, like previous video, we can initiate our wallet connected. This variable will allow us to see if our MetaMask is connected or not, and then we can define contract address and contract ABI. So we are going to copy our contract address here, and the contract ABI we are going to get it from here. Okay, so we are going to copy it and paste it, and then we can minimize it for better visibility. Okay, so first of all, our first function is const connect MetaMask. It's going to be an async function, and first of all we are going to define const provider is equals to new ethers dot providers dot web3 provider. We are going to use web3 provider always for MetaMask, windows.ethereum. Then we are going to say await provider dot send ETH underscore request accounts. Then we are going to say signer is equals to provider dot get signer, and then we are going to say wallet connected is equals to await signer dot get address, and then we have element is equals to document dot get element by ID, and the paragraph we defined is, we can see it's MetaMask notification here, and here it's same. So we are just going to say MetaMask notification, and element dot inner HTML is equals to MetaMask is connected plus wallet connected. So we have created this function. So let's start our backend server, and we can see the functionality. So if we okay, so let's just Yeah, so if we just go to localhost 3000, we can connect to MetaMask, and if we go inspect, what's the error? Connect MetaMask is not defined. Okay, I think we made some mistake in the function definition. So index.html connect MetaMask. Okay, so let's try again. Okay, so now we are going to put password and the MetaMask is connected, and let's go to this page and try. So our connect MetaMask function is working fine. So now we have to create a function. Let's create a function, get all candidates. So in main.js we are going to say get all candidates. It's going to be an async function, arrow function, and first of all it's here, the list is here, and we can say, we see this is the name of the function, so we are just going to copy and paste it so we don't make any mistake, and I think it's same. And if you see, this is the ID where we are going to set our status, like if we are getting the data or whatever. So we are going to say where element, no, let's call it p3 is equals to document dot get element by id, and we are going to say it's p3, and we are then going to copy this same thing. We are going to copy this same thing here, and then we are going to say const contract instance is equals to new ethers dot contract. We are going to initiate a contract with contract address, contract API, and signer. And then we are going to say p3.innerHTML. Once the construct instance is created, we can say please wait, getting all the candidates from voting smart contract, and then we are going to say where candidates is equals to await contract instance dot get all votes of candidates. This is this function we defined in the smart contract, and we can say console.log candidates, and then we are going to define table which we have created in the list voters HTML, get element by id, and the id of the table was my table. So if you go here, this is the my table, this is my table, and we are going to grab it, and then we are going to say, because this candidates, this it's a tuple and it has a lot of like values for candidate 1 and their vote count, candidate 2 their vote count. So we are going to loop through all this data, and I is less than candidates dot length or I plus plus. So we are going to add a row, insert row, where row is equals to table dot insert row, where we are going to say id cell is equals to row dot insert cell. Then we are going to say is equals to row dot insert cell, and then finally we have this vote count is no, it's VC is equals, and let's call it name cell const VC is equals to row dot insert cell. Okay, so everything is done, and what we can do is id cell dot inner HTML is equals to I, this is the index. Name cell dot inner HTML is equals to candidates of I dot name, the name of the candidate, and VC dot inner HTML, the vote count will be candidates of I, because it has a lot of candidates, so we can say it's the vote count. And and once it's done, this for loop, it means the data has been retrieved. So then we can do dot inner HTML is equals to the candidate list is updated. So let's go and try this function. Let's start our server again. Let's go here, list all voters. Okay, so you see we have this array, and in each array we have a name, and this is the name and this is the vote count, and then we have Mike and its vote count. And so if you see, we have these Mark, Mike and George. So basically if you go to scripts, we have input 3 names, and then this was the current time. So let's write the function now where we can get the status of the smart contract. So let's write it. We can say const vote status is the name of the function, and it's going to be async arrow function. We are first going to see if wallet underscore connected is not is equals to 0. We can say where status is equals to, because we defined, you remember we defined status and time, and we are going to update it here. So document dot get element by ID status, and where remaining time is equals to document dot get element by ID, and it's going to be time. Okay, then we are going to copy and paste the same thing. We are going to create the contract instance, and let's do this. So contract instance, and then we can say we are going to remove this const current status is equals to await contract dot instance dot the function in the smart contract is get voting status, and then we can define time as await contract instance dot get remaining time. So now we have time and status. So what we can do is status dot inner HTML is equals to, we can say current status. If it's true, then we can say voting is currently open, or we can say voting is finished. and time dot no remaining time dot inner HTML is equals to, we can use this to put dynamic variable remaining time is, and sorry, so this is the result is in hex, so we are going to convert it in decimal, and then we can say seconds. And this is the if condition else, where status is equals to document dot get element by id, and then we are going to say status dot inner HTML is equals to please connect MetaMask first. So let's go and try this function. If we go here, let's go here, check voting status, please connect MetaMask. Okay, I think we are, oh, we got this. So you see voting is finished and remaining time is 0 second, because if you remember when we uploaded our contract, the the voting time was I think 10 minutes or 20 minutes, I don't remember, but since I am creating these videos, so the contract is expired. We are going to upload the contract again, but this is just for the function that we are going in the right direction. And if we just go here, then our final function is, so if you go to index.html, this is the final function, add vote. So what we can do is we can say const add vote. It's going to be async function, and it's going to be arrow function, and again we are going to do the same thing. Now instead of status we are going to take name. If we just go to inner HTML, okay, so we have this ID of vote. We are going to take what's inside this input. So we are going here, name is equals to document dot get element by ID vote. So this is the name, and or we can say this is index or name, let's whatever. So we are just going to say providers equals to new ethers provider, then this is contract instance, and here we can say where candidate is equals to document dot get element by ID, and we can say canned. So if you sorry, if you just if you just go here, we are going to update the status here that please wait, adding a vote, or the vote has been added. So we are just going back here, and we are going to say can dot inner HTML is equals to please wait, adding a vote in the smart contract. And what we can do is const transaction is equals to await contract instance dot vote. This is the name of the function, and we can say name dot value. So basically name is the input field, and we are going to take the value. And what we're gonna do now is await tx dot wait, and once the transaction is finished, we can say can dot inner HTML is equals to vote added. So once the transaction has been sent to the blockchain, we are going to say okay, the vote has been added. And here we can just grab the same thing, and instead we can say please connect to MetaMask first. So let's go and try I think we have completed the application, so let's go and try it. So let's go. First of all, list all candidates. Okay, so the candidates are updated and this is the candidate. So I think we need to upload the smart contract again. So I'm just gonna go and npx hardhat. Yeah, okay, so the contract has been updated. So let's first update it here and then update it here. Okay, so let's start our server again. So if we actually go to here, vote, first of all we are going to connect MetaMask and check voting status. Voting is currently open and it's 4480 seconds. I don't remember how much time I have put, but like for 4480 seconds the contract is still here. And let's go and list all the candidates. Okay, so these are candidates, and let's say we want to add the name of candidate, let's say Danish. We are going to add a candidate here. I hope it works. Okay, so the candidate has been registered in the smart contract. So let's connect it, list all candidates again. Okay, it's overwriting, list all candidates, and you see Danish is here at number 3, at number 4 actually, but in the index is 3. So we have checked this functionality of MetaMask, we have listed all the candidates, we have added a candidate, and now let's go to vote and let's vote Danish. First of all, connect MetaMask and let's add a vote. So it's going to take us to MetaMask to confirm transaction, and it says please wait, adding a vote in the smart contract. And once the transaction is finished, it's going to change this text, vote added. I think that's what I have written there. Yeah, so vote added. So now in order to check it, we can just connect MetaMask and list all candidates, and you see Danish has 1 vote. And if you go to vote and check voting status, okay, please connect MetaMask first. Voting is currently open and it's 4245 seconds. And if we want to confirm if the time is changing, we can say it's 4197. So the time is constantly decreasing, and there will be a time when the voting will be closed and nobody will be able to vote to the smart contract. So that's all for this project. I hope you have learned a lot from this, and in the next video we are going to create a Docker container, and we are going to upload the code, build the Docker container and upload it. We are going to upload and use it in our local computer, but you can always upload it to Amazon EC2, or you can upload it to like any your own server, or you can upload it on cloud or Heroku or like anywhere. So basically that was it about this project. So we will come back with new projects on blockchain based applications, the decentralized applications. So thank you very much for watching and see you in the next video. So we completed our application in our previous video. So in this video we are going to create a Docker image of our project, and we are going to upload it in the Docker container. So let's first create Docker file. You need to make sure the name of this Docker file is Dockerfile, and the one thing which we need to do is, instead of test, we can say np start and node index.js, because index.js is our main file. And so let's start writing the Docker code, and we are going to use node 16 Alpine. Alpine is, as I explained in my previous video, this is just a lightweight Linux OS with the node installed in it already, so we don't need to install node. And then we are going to define work directory app then we are going to copy everything in app directory, then we are going to install npm, no, we are going to run the command npm install. So basically the Docker, these are the commands. So first of all, it's going to take this image, create a working directory /app, then it is going to copy all this content in the app, then it's going to run npm install, and then it's going to expose the port 3000, not post, port. And once everything is done, it is going to run the command npm start. So basically this is our Docker container, and we can say docker build -t, this is my name, /voting app. Fill to docker unknown instruction. Okay, we can see all these because I have created docker build -t. Let's try to create it, voting app. Okay, let's try to do this. Load build docker transferring, failed to solve with front-end docker file .v0. I think we are making some mistake with docker. npm install from node 16 alpine work direct. Okay, we have created a mistake here. So let's try doing, yeah, so it's working now, it's building the file. We always create some mistakes and it's difficult to debug the code sometimes, but yeah, it's okay, we always learn from our mistakes. So that's why I don't remove these mistakes in my video, because maybe you might make the same mistake and you don't have to go to Stack Overflow. So let's wait for this image to be built, and then we can run this Docker container. So let's just wait for it. It's taking some time. Okay, so docker image ls, and here we can see we have the directory, this Sayyid Danish 1992 voting app. So let's say docker run -p 3000 Sayyid Danish 1992 voting app. Let's try to run this. Okay, so the app is listening on port 3000. So let's go here. We can say localhost 3000. It's our same. Let's connect. MetaMask and check voting. The voting is currently open because I am creating the video right after my front-end main.js. So we see the voting is currently open and the remaining time is 864 seconds. I think when I was previously creating a video, it was around 4000 seconds around. So that's how we can upload this application in Docker container. And now you can take this Docker container, you can upload it to the Docker Hub, and then you can maybe log into the cloud using SSH, and then you can run the container in the cloud directly, or you can run the container in your own like favorite server, or you can build your own server at your PC. So basically that's how you are going to create the Docker container and it's going to run your application. So yeah, that's it for this video. So thank you very much for watching. Bye bye.